Good afternoon. Welcome to another webinar of the series iTAC Live on Stage. Thank you for joining us today. Let me introduce us as iTAC Group. My name is Roller Glade. I'm Senior Sales Manager at iTAC Software AG.
My name is Markus Raab and I'm Head of Sales Planning Solutions at Dualis.
My name is Martin Köster. I'm Sales Manager from Dualis too, and I'm responsible for the area Factory Simulation.
Yeah, thank you, Markus and Martin. We would like to present to you today's topic, the closed loop approach, the interaction of simulation, APS, advanced planning and scheduling, and MES/MOM. How can you boost your output to get more transparency, productivity and efficiency in your production? Before I start, I would like to give you a preview of our next two webinars. The 26th of April, MedTech, Simplify Production Processes and Increase Efficiency. That means complete traceability, full compliance with the norm and quality assurance in our MES/MOM. The 21st of June, new possibilities in the manufacturing world with flexible production. That means automatic control of material flow and optimized production utilization. Furthermore, you are welcome to request the already broadcast webinars from our website. Let's move on to today's agenda. We divide the three sub-disciplines, MES/MOM, APS and simulation between us. I will show you which functions, or which basic function we need for the closed loop approach. After that, Markus will introduce the planning philosophy of our APS service, and Martin will show the possibility of what is possible in a modern 3D simulation. And then it gets exciting. We will show you the closed loop approach. What does it mean when three systems work hand in hand together? And the point 6, the Q&A session, it's your turn. In the navigation bar below right, you find the button for the chat, and here you can ask for questions from now on, and we will go into live at the end. Functionally and professional, we have a wide range of different functions on the board in our standard software. We have the models of APS and simulation on board in our MES/MOM systems. But the idea, the motivation is how can we focus production excellence when three sub-disciplines work hand in hand in an operational business together. Let's have a closer look to the next slide. For the closed loop approach, we need the MES systems, which the basic function models, production management, traceability, and if you need more analysis, we need the business intelligence as well, APS and simulation. Production management provides you with feedback from the shop floor, individual machines and the manual workstation back from the production. You get the information of KPIs, evaluation. This is the basis for the calculation of the OEE. You receive the feedback in real time. For you, this means that you always knows what your KPIs look like. The traceability model provides you the document life cycle of a product. Here you can evaluate the process times per order or per unique item. And if you want, the BI, the business intelligence models, can support you for further in-depth analysis. The special feature of our BI, of our business intelligence service from Click, is that we provide is an alert service. Markus, we have the APS, the Advanced Planning Scheduling Service, fully integrated in our MES system. Can you introduce the planning philosophy, the audience on the screen?
So the planning philosophy of our APS module is actually based on three main topics, which you can see here. First of all, there is the automated order scheduling against finite capacity. During this automated scheduling, there is also the possibility of an optimization. The optimization is based on 7 target criteria. These criteria are, for example, the optimization of the utilization, the optimization of the on-time delivery, or the reduction of the production, personnel, or setup costs. The second topic, the so-called multi-resource planning, a very important topic. What does it mean? The APS module is not just able to take into consideration the required machines, stations, or manual work centers. Furthermore, it's also able to take into consideration the required personnel and their skills, required operating resources like tools or transport boxes, and for sure the required material for the production order. Doesn't matter if it's purchased material or material which was produced on your own. The last topic, the interactive planning. For sure, we're also visualizing the planning results on a so-called Gantt chart. On this Gantt chart, the highest possible transparency is the most important thing. And therefore, there are a lot of configurable views and color schemes that the users of the software, so the planners and the schedulers, see very fast the informations they need to see and would like to see. Furthermore, it's always possible to do manual changes in the Gantt chart. Therefore, there is also a menu where you can change the settings regarding the restrictions and rules for the manual planning. So what are now the specific benefits by using the MES/MOM system together with an integrated APS module? First of all, a global instead of a local optimization will be possible. So what does it mean? So there's not just the optimization of single areas, which for sure can cause some problems in other areas of the production, but with the integrated APS module, the connection with the MES/MOM system, it's possible to have a global optimization through all operations, processes, and levels. Second benefit, for sure we are receiving the confirmations from the shop floor in real time from the MES/MOM system in the APS module. Therefore, we have the current state in the production in the planning, and the planning is capable of to react to this current state fully automated. Furthermore, transparency and synchronization along the complete value added chain. So you really can see the impacts of one area on all the other areas and see very early if there will be a problem and can react to it. For sure, because of the optimization, there's also efficient usage of all required resources possible, and therefore also a very early discovery of possible bottlenecks. Also, because of the optimization with our 7 target criteria, there is also the reduction of lead and production times. Therefore, this leads to a reduction of the WIP, the work in process. And the last point, because of the cost optimization, there is also a decrease of production costs and setup costs. Production costs, especially by choosing the best available alternative for a production order, and the reduction of setup costs based on our 3-dimensional setup optimization. So Martin, can you please give the audience an overview to the topic simulation?
Yes, thank you. Yes, simulation is an interesting thing. I explain it a little bit like a computer game. Look, you have many components already there. I would say at least 3,000 components which are already there, and you can put it in the model quite easy with plug and play. You can put on your model, like your shop floor, for example. You put on the rules, the behaviors, and at the end, you put in the orders. Later on, you will see what happens. You can analyze the system. You can look, where's my bottleneck? You can think about how many people do you need in such a layout? Or, do you need buffers? How big should these buffers be? And so on and so on. You can answer many questions with a simulation tool. And so you have many benefits coming out of this game. Maybe the most important is to avoid errors. Because you can plan everything else, everything in this virtual world. You can test everything else. You can try out many scenarios. You can compare different scenarios to find the optimal one for you and for your shop floor. And because we are talking about a 3D simulation, the 3D world is the world we are living in. It is quite easy to understand what will happen there. You can dive in the simulation with a VR glass and look around. You can see how big the hall should be. You can even discuss with your colleagues. You can show them your solution. Discuss with them if it is the optimal one or maybe if you have to do some changes. And at the end of the day, it is nearly risk-free because you must not hire any workers first. You must not buy any expensive machines or something like this. It is only, first of all, in your digital twin. And you can try and you can find the best solution. But it's not only a game. You will get out many results, KPIs. You will find your bottlenecks. You will have statistic figures. And you will get a complete documentation about it. So you even later can compare your scenarios and you will find the best solution. Hopefully even for your situation. I think it is very important that a simulation is not too complicated. If it is such a thing that you need half a year to learn about it, no one will use it. And so we can offer you a simulation which is easy to use and which helps you immediately to find a good solution. Maybe you do not know, but the simulation is not only a standalone solution. You can combine it with CAD things, with PLCs, and that is exactly what we want to discuss today, with an MES system. We can use the data coming out of the MES system, the orders, everything else we can put in our simulation, and then you will see later what will happen. At the end of the day, I think it's a good price-performance ratio. So maybe you will be surprised how cheap it is. So maybe you try.
Martin, yeah, thanks. Yeah, once again, the information of the QA session below on the right side. There's the button for the chat. And yes, send us your question, and at the end we will go into it at the end. Yeah, now we have, or you have a short overview about the models, about the APS service and the simulation, and now we would like to present the closed loop approach, which is also represented under the term the model-based manufacturing. What is the task in this case of the MES.MOM.Suite? The task is that the MES.MOM.Suite is a database. We have full integrated APS service in our MES suite on the same database. We have the bidirectional connections between MES and simulation. The MES system is a database, or the data hub for sending and receiving information between simulation and APS service. Yeah, what does this exactly mean? The MES systems receive the master data and the transaction data from the higher level ERP, which can be, example, a work plan, the bill of material, or other informations. Supply of the results of the simulations into the MES system as a data hub. Supply of actual data from the MES systems as feedback for the APA service. So now on this side you see possible use case. Martin, in the greenfield environment, how can we use the closed loop approach? Can you please introduce or give the audience on the screen some information how can support the closed loop approach?
Yes. I think a greenfield use case is a typical use case. And it's maybe a good start for the closed loop too. If you have a greenfield, you have maybe an idea what your system has to look like, but there's a white sheet of paper. And then the simulation helps you very easily. You can put your components in the model, you can make it run a little bit, you can try out many things. And so I would say, yes, greenfield is a very good start for closed loop.
Yes. Martin, I remember I had some customer discussion, and the internal logistic is in the term in the transport control. So the raw material is in the warehouse, and the material flow from the warehouse to the machine, something is wrong, we have a delay. How can I help the closed loop approach in this case?
I would say material handling, material flow belongs to the DNA of the simulation. We have in our simulation many conveyors, for example. We have forklift trucks, overhead conveyors, robots, everything else you need for this. And even buffers. You can exactly answer the questions by putting buffers at different sites in your model, and then you can discuss if the buffer is too big, the buffer is too small, if it is the right place for a buffer. Yes, you will see later on it is a very big item, and I would say yes, simulation can help you, even in material handling.
That sounds good. Thanks. Markus, in the brownfield environment, something is changing. We have a new product, something else. Can you explain the audience on the screen how can I help the closed loop approach?
Yeah, I really think the brownfield use case is very interesting for many companies. So just imagine you have an existing production plant and existing machinery, and then there is an external impact, for example, additional products, additional demands, and then for sure it's very important to have a closed loop approach, a simulation, to see which measures, which investments, which adaptations, which changes are necessary to be able to fulfill, for example, this additional demand.
Yes, thanks. Yes, we have prepared one case that is in the brownfield. Something is changing, a new product is coming, and now, Martin, can you introduce the layout?
Yes, okay. We prepared a special layout for you, a use case here. Look, we start here with a pre-production. The pre-production is delivering different products. You will find out we have brown products and we have blue products. These products are transported to an area, the brown ones, product number 1, to a manual assembly area. Here human people have to do some additional work. The blue boxes directly are transported into a test area. Here the high bay warehouse in front of it, and a robot then puts the blue box into machines. Later on, the box will go to this later high bay warehouse, and you will see there will be a packaging area, and then is a dispatch. So that is the use case. We want to look a little bit more in detail. And Markus, I want to ask you how this look in your system.
First of all, we are in the data area of the APS module. Here we can see all the received master and movement data from the MES.MOM database. Based on this data, we will now start the automated scheduling. Therefore, we go into our planning cockpit and click the start button. Now we can check the result on the Gantt chart. First of all, we can see here that all of the 14 production orders are scheduled on time or early. So all the production orders can be delivered to the customers on time. To see that fact more in detail, we can change the color scheme to delay traffic light, and now we can see with the green color that all of the 14 production orders are on time. Let's check the planning model more in detail. On the left hand side you can see the test stations, the 6 test stations which were already shown by my colleague Martin. Then we have our 6 assembly stations and our personnel group with 4 assembly workers. Let's check the order view, for example, of production order number 6. Therefore, I click on the order and open up the order view. Here you can see for production order number 6, first of all, the operation on the assembly station together with our assembly person. Afterwards, we have a static waiting time of 10 minutes, and after this 10 minutes, we have the operation on testing station number 4. So in the scheduling area, everything looks fine. Holger, you can start the production.
So we have the results from the APS service, and yes, I give you some background information. I'm registered here on the station AS0101, and now I can start the order 1 to activate the order. And after the activate the order, you have here some additional information here in the sidebar. For example, here's the part number, product 1. You see the works tab here is started. You have here some additional information about the target. In this case, it is 15 pieces, and you have more information about the current. Is it a pass, fail, or scrap?
Now we will check all the received confirmations from the MES and MOM system in the APS Gantt chart. First of all, you can see here that all operations are completely finished. You can see that with this gray area down to the operations. And second, you can see that all of the production orders are still green. So the scheduling is the reality. All the scheduled orders have been executed like scheduled.
Yes, but guys, to be honest, if I look in the system here, that is nearly a little bit boring. Look, people are waiting for new products, new orders. The high-bay warehouse is empty. Nothing happens here. If I look in the statistic figures, for example, maybe we start with the machine stations here. Look, the idle percentage is about 40%. So the machines, they are not doing anything. The manual operators, for example, at least I would say they have a utilization of 65%. So to be honest here, that is not a very good example for a hard optimization, or what do you think?
Right. I have the information from the management, and we have an additional product. In this case, that is product 3. And Markus, we can be implemented that we need a closer look in our APS service.
Yeah, and now we have the additional production orders for product 3 here in the APS module. Based on this additional production orders, we are now starting our automated scheduling run again. Let's check the result on the Gantt chart. Now we can see down here that there is a problem. Right now, with this additional orders, because of the additional product 3, we have now 19 production orders on time. So that means they are critical. And furthermore, we have 2 delayed production orders. So let's check one of the delayed production orders and see what is the reason for it. Therefore, I'm clicking on a delayed, so on a red production order, and open up the so-called scheduling analysis. in the analysis, I can see here directly that the problem is a bottleneck in my personnel for the assembly area. With the information from the analysis, we are now back in the data area of the APS. More precisely in the master data of the worker group. Here we have our assembly team, and we can see here we have a maximum capacity of 400%, which means 4 people. So based on the information of the scheduling analysis, we are now increasing this value to 600%, which means 6 people. After this change, we are now starting the automated planning run again. Let's check the result on the Gantt chart, and as you can see down here with exactly the result we were waiting for. After the measure with 2 more assembly workers, we now have again 21 orders on time. So from my side, everything looks fine. Holger, you can start the production.
Yes, I have the results from the APS service and I can start the production line. So I activate the order. So here on this button, so you see it is green. I have the additional information here in this sidebar.
So now when we received all the confirmations from the MES.MOM system in the APS Gantt chart, we can see that there is a problem. First of all, again, we can see with this thin gray bars that all of the operations are completely finished, but all of the operations are additionally red. To see more in detail the reason for that, we are switching into a utilization report, for example, of testing station number 1. Here we can see the reason for the delay of the production order. 2 times we allocate the testing station number 1 more than the available capacity, and for sure that is the reason for the delay.
Martin, what could be the reason for that? Have you an idea?
Yeah, let's have a look in our digital twin here. You see now I have included 6 workers and the new product, the red box here, and the simulation looks completely different. Yes. If you look inside the simulation, we see, oh, the buffers. Now we have some boxes inside the buffers. And maybe that could be the reason. If you look in front of the buffer, you will see there's a traffic jam already here in front of the buffer, and that leads us maybe to the real problem. If I look in the statistic figures, for example, and we start with the buffers, then you see, oh, look, the buffers are nearly full now. So even if a buffer is full, you have to look more in detail. If I even look in the robot utilization here, I see that the stacker crane, the yellow line here, it's increasingly nearly to 100%. So I guess the problem in the situation is the buffer. Markus, what do you think? Have you seen this in your APS system?
Yeah, Martin, waiting times or dynamic waiting times are normally not part of the classical routing in the ERP system. And yes, our planning is based on the routing, and therefore we couldn't see the problem.
Okay, so it is a guess, but we can play around a little bit because we are here in the digital world. I would suggest to put another high bear stacker crane inside, because I think that could solve the problem. What quite often happens in such systems is that if you have a problem, it looks a little bit like a motorway. You enter a traffic jam, for example. You stand there for half an hour. After a while, you come to the end of the traffic jam and you're wondering yourself because nothing is there, no accident, nothing else. And then you're wondering, hey, what was the problem there? And then you figure out that, okay, you have a problem on the motorway. A traffic jam starts. After a while, the problem has gone. The first cars are moving out of the traffic jam. But while they are moving out, new cars entering from behind the traffic jam. And that leads you that the traffic jam by itself is moving over the motorway. And that is a very crazy thing. And you can see this in statistic figures when they start to swing. And normally such systems are swinging in many ways. And later you will see that the problem you will have here with a high-bay warehouse, it will come to the workers later on to your pre-production. So I would suggest put in a second stacker crane. What do you think?
Great, Martin. That's what the simulation is for.
Okay, guys. Now we've put in a second stacker train. And now we see, okay, both are moving. The buffer is not as full as it was before. And if we now look in our statistic figures, they are looking quite nice. The OEA, for example, we have here 91%. Okay, I think we can increase it a little bit more. Our manual operators, they are by nearly, they are by 90%. But I think, okay, that's fine. For me, I would say the system is working. Markus, what do you think? If you reduced the time in the buffers by 35%, would that help? What do you think?
So let's check it here in the new routing which we received from the iTAC system. As you can see here, we have now our time, our waiting time in the buffer reduced to 6 minutes and 30 seconds instead of the 10 minutes at the beginning. Based on this new information, we are starting our automated scheduling again and check the result on the Gantt chart. And as you can see, all of the 22 production orders are now on time. So it seems the measure with the reduced buffer time really works. From my point of view, Holger, you can start the production.
Yeah, okay, the results from the APS service, and I have a fit, so I start the order again to activate the order here. And here's the button to activate the order. The order is starting now, and you have here see the sidebar with the additional information.
So, and now finally we received again all the confirmations from the MES.MOM system. And you can see here again with the gray thin bars that all of the operations are completely finished, but now with a different result. All of the orders are visualized in a green color, which means they are all on time. So the measures which we saw in the simulation really worked. We can now deliver all the products on time to our customers.
A nice example of how important can be used simulation with the MES.MOM systems in combination with the APS service. We can simulate and plan on one database. We have a continuous improvement through a digital twin. Martin, you just told of dynamic processes. In the example of the traffic jam, can you explain the audience what is the added value in this case?
Yes, if you have a dynamic problem, for example, like I showed you in this as kind of traffic jam, these jams are moving through your shop floor, gaps are moving in the other direction, you will find out you can't solve this with an Excel sheet. It is nearly impossible. Another example is if you are planning an AGV system, for example. You start with one unit. Yes, you look where are my transports and so on. You start with one unit, then you put in a second unit. Okay, a second unit you will have twice the throughput than with one unit. But if you put more and more units in the system, the problem starts. After 10 units, you will feel that one unit has to wait to another vehicle, and at crossings they can't move because they have to wait. And if you have then a big AGV system with 50, 100 units, for example, I would say it is impossible to solve such dynamic processes without a simulation.
Yeah, thanks, Martin. Yes, in a simulation you can simulate a month or of more, and you save time if you see it in 10 minutes or under 10 minutes, for example. And Martin told us VR glasses, you can diving into the virtual production and you can see it. And yes, and how can the closed loop approach to get maximum out of your operations? Yeah, now the Q&A sessions. Markus, have you some questions from the audience?
Yes, there are already some very interesting questions. So, first question regarding simulation. Martin, can you please? First question is, which use case is simulated more often, greenfield or brownfield?
I would guess it is a 50-50 thing. Both use cases have their own questions, which you can answer very good with simulation. If you're in a greenfield, maybe you have no other chance to use a simulation because you have nothing else, yes, and you can start to put everything in your model, you can test it, then the simulation is quite a strong tool to answer this question. And in a brownfield, you often have the problem that you can't change your shop floor. And then the digital twin helps you to consider first which is the right solution for you. So both makes sense, and I would guess 50-50 is the right answer for this.
There is one more regarding simulation. Martin, in average, how long does it take to build a simulation model? Can you give an answer to that?
Yeah, the good question. It is, maybe the similar question is, how much does a car cost? And there are different cars and different costs. But I would guess, if you ask me personal, if I look in our experience, a normal shop floor, one hall, it will take, I would say, 2 days till maybe 2 weeks to put the model together so that you can analyze it.
Okay.
Yeah.
And there is one more, Martin. Please wait a second. One more comes in. And the question is, do you offer training sessions for simulation, or is it more learning by doing?
A good question. Both is possible, to be honest. We have special videos where you can learn by yourself. We even offer you the software. But okay, with the training, you will get much faster to the end of what you want to do this. But by the way, even if you do not want to do it by yourself, you have the possibility to ask us that we give it to you as a service and we do the simulation to you too. So you must not do it by yourself. Even that is possible.
Okay, thank you, Martin. So there are also some very interesting questions regarding the planning part, the APS module. First of all, there is the question, which master data are mandatory for the APS planning module? So to be honest, it's a very easy answer. So there are 3 types of data which are really essential for building the APS planning model. First of all, it's the material information which you need. Secondly, there is the routing with all the times and the machines, and for sure the waiting times, which is also mandatory for building the planning model. And last but not least, for sure, the machine or the manual work center on its own. But based on these 3 types of data, and additionally with the work orders or production orders, it's able to build the planning model in the first step and then do the automated scheduling and optimization. There is a general, very interesting question here. I think I can answer that too. The question is, what was the motivation for iTAC to offer the closed loop approach? Yeah, I really think the main motivation for iTAC was to provide something really unique for our customers and prospects. So for sure the iTAC group, so the combination of iTAC and Dualis, can provide with their experience and their products in the area of MES, MOM, APS and simulation a real USP on the market, and therefore I think that was the main motivation. Let me check if there is... Yes, there is a question. The question is, can this be integrated to an older version of our MES? Yeah, to be honest, it's difficult to answer that question. I don't know your version exactly, but nevertheless, for sure, it would be a good thing to do an update before implementing or expanding to the closed loop approach, because only with, as you all know, only with the latest versions there are all the new functionalities, all the performances in the interfaces available, and therefore, yeah, unfortunately I cannot give you the exact answer to your question, but for sure an update would be a good idea. Yeah, then there is also one more question regarding planning. The question is here a little bit longer. How does the APS system would access the availability of materials, production tools, machines before scheduling the production order or work order? Does the system know the materials quantity, tool status and machine availability before scheduling the production? Yeah, very good question. For sure, the APS module received the information about the stock levels via the MES MOM database, which get this information from, for example, the warehouse system or the ERP system. And regarding the status of the machines or the status of the tools, for sure we are getting fully automatically this information out from the MES MOM database into the APS planning module, and therefore, yes, we have all your asked informations in our planning model, and the system can consider the material availability and the status of the machine and other operating resources. Yeah, here we have one more question. Yeah, very good question. Concerning APS, what is the difference to use APS combined with MES instead out of the ERP planning? Yeah, I think the huge benefit by having a MES system in between is that, as I already mentioned on one slide, is that for sure the MES MOM system gets the real-time information from the shop floor, and for sure the real-time information from the shop floor, so the confirmations from the workers, from the machines, is a very basic information which you need in the APS planning module. And therefore I think that's the biggest advantage by having the MES in between, because if you're just connected to the ERP system, for sure this real-time information from the processes, if there is an interruption, the confirmations is something which is missing, or for sure not in such short term, in such short time available in the planning model. Yes, then there is one more question, Holger, for you. The question is, where should we start in the closed loop approach? What is your recommendation?
Yes, for example, if you start in the brownfield environment, yes, you have the MES MOM system in the production, and you have the APS service on board, and that is in this case where you start, and then you have the simulation and you have the closed loop approach.
Thank you, Holger. So yeah, we are almost at the end of our today's webinar. Holger, you have some more very important information for our audience?
Yes, that is correct. Yeah, once again, the information for our next two webinars, the 26th of April, MedTech, Simplify Production Processes and Increase Efficiency. the 21st of June, new possibility in the manufacturing world with flexible production. Furthermore, you are welcome to request the already broadcast webinars from our website. Yeah, now we have reached the end. Thank you, and yes, you are welcome. If we have some additional question or information, write us an email, info@itacsoftware.com. The next month, the Hannover Fair from the 17th to the 21st of April, we are in the Hall 15, stand E34. Yeah, and therefore,
Think big.
start small.
Scale fast.